I like to talk about the topic 2, which is the perceptron. And the first is the main method. The perceptron is a binary classification algorithm designed for linearly separable data. It works by, iteratively finding a decision boundary that separates two classes. And the algorithm starts with random weights and keeps correcting misclassified points until all data points are properly classified. This iterative correction process is what makes the perceptron so powerful for linear separation problems. And then for the tools we used the vector dot product to measure similarity between feature vector and weight. And in our code, this appears as a dot, which is this, and the vector addition is used for weight update with this part, and the hyperplane equation, which is this, defines our decision boundary. And these linear algebra operations are fundamental to the algorithm's operation. And then we can go to the coding part, which is here. Now let's look at the Julia implementation. And first is the generating part. We have generated a linearly separable data with positive class clustered around 2, 2, and a negative class around -2 and -2. And we have made a random seed, which with my student number on it, ensure reproducible result. And our data generation creates two clearly separable clusters, which is perfect for demonstrating the perceptron's capability. And then for the training part, which is the core of the training function, we have initialized weights to 0 and then iterate through maximum iteration. And for each data point, we compute prediction using sign, which is here. And when this classification occurs, we update weight with this part and bias with this part. And the algorithm stops when no misclassification remains. And then for the result, this is the result part code, and here is the result. And our module converged in just 2 iterations, successfully separating all 60 data points. The decision boundary is made by this, which is perfectly distinguish both classes. And the visualization, which is this part, shows the blue circle for class positive and the red cross for class negative, with the black line which represents our optimal decision boundary. And now for the verification part, which is this part is the code, and which is the key theoretical aspect is where is the perceptron's convergence theorem, and we calculate R as the maximum data norm and K as the minimum margin, and the theorem guarantees convergence within R divided by K square iterations. And in our case, R is here, which is approximately 4.98, and the margin, which is K, is about 0.85, and the theoretical bound is 34.25, and which is much higher than our actual 2 iterations, advocating excellent our data separation. And now for the limitation and solution. And the perceptron has limitations. It cannot handle non-linear separable data. However, we can overcome this by mapping data to higher dimensions or using multi-layer perceptrons for non-linear boundary. This connects to more advanced machine learning concept. And for application part, the perceptron have practical applications in email spamming filtering, medical diagnostics, and sentiment analysis. In each case, we are essentially performing binary classification based on feature presence and weight. And for conclusion, we've seen how linear algebra powers this fundamental algorithm, from vector operations to convergence guarantees. The perceptron remains a cornerstone of machine learning, providing insights into more complex neural networks. And that is all.